first question is a match-up one. I would suggest the first thing you do is look for the perfect square for each one. So x squared plus 4x is going to use the perfect square x plus 2 squared. X squared plus 12x is going to use x plus 6 squared. X squared plus 12x, again, x plus 6 squared. X squared minus 12x is going to be x minus 6 squared. X squared minus 3x, we could use fractions or decimals here. I always tell you to use fractions, so of course in the MyMaths one they've used decimals. And finally, again, minus 3, which becomes x minus 1.5 squared. When we look at these, we can see we've only got one that uses the perfect square x plus 2 and only one that uses the perfect square x minus 6. So those are pretty simple to match up. This one is the only one with x plus 2 and this one is the only one with x minus 6. So those two are pretty easy to match up straight away. We've got 2 of x plus 6 and 2 of x minus 1.5, which is where we start to use the idea of completing the square. So let's write out for each of these ones. We've done that one and we've done that one. So let's write out what the perfect square would be. X plus 6 squared gives us x squared plus 12x plus 36. What do I need to get to? I need to get to plus 0, so I need to subtract 36. I'm going to have x plus 6 squared subtract 36. And if we look, that's down here. So this would be this one, completed, which then means this one has to be the other one with x plus 6, which is that one. Now for the bottom two. X minus 1.5 squared is going to give us x squared minus 3x minus 2.25. Sorry, plus 2.25. You always have a plus on the end of a perfect square. So we don't want the 2.25, we need to remove that. And when we look over here, we've got one that has minus 2.25 on the end. That one is going to be there. And finally, this one would have to be this one. Process of elimination more than anything else.